Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at geometric regression. Now geometric, it's very similar to linear regression we already saw. The difference is the curve or the line that we're going to fit. Whereas with linear regression the line is straight, with geometric regression, effectively the line that we may fit to the data is in fact curved. So for example, it may be a line looking something like that. So everything else about this is exactly the same as we already saw with linear regression. We're working with a single explanatory variable here of income, and so now let's have a look at the code and see how that all works. Here we can see our input dataset in HANA Studio. We can see we've got lifetime spend as the dependent variable, with income as the explanatory or independent variable. What we want to do is to have the predictive analysis library draw a geometric regression line or a power curve that best fits this set of data. So what we need to do is to go to the code. The code is pretty much the same as you've seen already. Again, a single explanatory variable here of income. We need to create the same data parameters, coefficient, fitted and significance tables, and if we want a PMML output we need to create a table for that as well. The major difference is that in terms of calling the wrapper generator we need to specify a different algorithm. In this case we're putting as a prefix to regression geo for geometric regression. So that's the code that we're going to run. Basically everything else is basically the same as we've already seen. So let's run this code and we will create that, and it's now performed our regression model. If we were to then refresh our set of tables, as always we can see that we've got the coefficient table, so we can have a quick preview of that. We can see our A values, so we have 4.56 and 0.2, which then is applied to our income variable. So that's the equation that the predictive algorithm is going to use. That's effectively the heart of our model. What we can also see is the significance table, which gives us the information on R squared, which is 0.7 in this case, so maybe not quite such a good fit as the linear regression was, and our F value, which again we can interpret using the F distribution in the way we've already seen in the other videos. So we can see the significance values, and of course we have all of that model information put together in PMML should we want to actually transfer that information to perhaps a different system. We can also go to our views, and if we refresh we can see a view we created of fitted information, and if we were to preview that and choose analysis, we can see as previously we've seen in examples, we've got the income and then the lifetime spend. So we can see income against lifetime spend, but if we were to show the fitted value instead of the lifetime spend, the fitted lifetime spend, what we now see, effectively that is the geometric curve that was fitted to the data, because it shows all of our input data points as fitted to that model, so that curve we've created. So you can use the fitted table and maybe join it together with your own original source data to, for example, with income, so that you can get a good visual idea of the chart that's been created, effectively the line that's been fitted. So now we've seen our fit and we've evaluated we want to use it, we then would need to start to predict some values. Of course, that's what it's all about. So again, it's almost the same code as we've already seen for simple linear regression. The only real change here is that the algorithm we call has changed its name. Instead of forecast with LR for linear regression, it's forecast with GOR for geometric regression. And of course you can look up that in the manual. You can find the specific text you need to put into this procedure call in the documentation, so no need to learn that by heart. Again, we can run the code. We can provide our input values as previously for a couple of new rows in our data. We can run this, and what we will see in the results, if we are to refresh and we look at our predicted view where we've joined on the original data as well, what we can see, we've got a couple of new rows at the bottom where we have our predicted values for life spend, for IDs, customers 151 and 152, based on the input of income that we provided. And again, if we were to analyze that and just quickly show the information and perform a plot, we can see based on that geometric line, we can see here are the predicted values for 151 and for 152. So that's how we've seen geometric regression. Now, of course, with linear, geometric, exponential, and other types of regression, it may be that you want to run several of these to work out which of the regression models, which curve effectively best fits the data that you're working with.